This is Geometry Lesson 7-4, Similarity in Right Triangles. Our goal is that by the end of this, you will be able to use similarity in right triangles. This is just going to be the first little part of notes, and we'll talk about the rest in class. So there's this thing you have to remember that when you draw the altitude to the hypotenuse of a right triangle, you actually form three pairs of similar right triangles. So you might want to just sketch this part up here with me. So essentially today, we're going to be dealing with right triangles like this one. Okay, we got a right angle up there at the top, and when we draw down this altitude, it'll be perpendicular to the other side, so this is referred to as our altitude. And there are kind of three triangles here that have relationships. So there's a little triangle, there's a medium triangle, and then there's the green entire triangle that I drew originally. And so we're going to be talking about those three triangles today. Okay, so essentially this says that the altitude of the hypotenuse of a right triangle, so that drawing that line in, divides the triangle into two triangles that are similar to the original one. So here we can see we have our altitude drawn in, CD. It creates this little blue and this medium green triangle, and they are similar to the original one. You can see that these three angles correspond. Our D, and our C, our A, and our C correspond, and then our C, our B, and our B correspond. And because of this, there's a lot of really cool things we can do that we'll build to eventually, but for now we're going to try to set up some relationships. So identifying similar triangles. It says, what similarity statement can you write relating the three triangles in the diagram? So here's my large triangle, divided with an altitude through it like this in blue. I might first start by writing the name of the large triangle. So I say triangle Z, X, Y. Now I find it a little bit difficult sometimes to see right away the relationships between the three triangles from the original picture. So what I like to do is I like to take the medium and small triangles and redraw them. So if this is my medium triangle here, I'm going to draw it so it has the same orientation as the big triangle. So you got your right angle on the bottom right, and it looks like this. And then a lot of times I kind of copy those measurements over. It's easy to find the right angle. In the medium triangle, that's a W, so I'll put a W there. And then you can see there's kind of a short leg and a long leg. I can see the short leg here is going to be WY, and the long leg here was WZ. So my triangle is going to look like that. And now I can kind of see what corresponds, so I can write my similarity statement up here. Well, in the big triangle, Z was this right kind of one, and so it corresponds to Z, the right in our medium. In the big triangle, the next one is X. Okay, that's attached to that little leg. Well, attached to my little leg right in that same spot is Y. And then if I check last, they had Y at a right angle in the big triangle. I have W at that right angle, so those are going to correspond. And now I try to do a similar thing with the small triangles. I'm going to write another similarity statement. I'm going to find the small triangle in my picture. I'm going to redraw it so it has the same orientation. Give it its right angle. I look for that right angle. It's here at W. I put W. And then I have a short leg and a long leg. I can see my short leg here at WX, so I'm going to put an X there. My long leg here at Y, so I put a Y there. And now, once again, I try to line up all my parts. So I started with Z in the medium and the large. And that was my far left one attached to my long leg. That's going to be my Y for the small triangle. And then I look next, I had X and Y, which were each attached. X and Y to the small leg. Well, attached to my small leg again is X. And then that leaves me with the right angle, W. So that would be the similarity statement I can write relating the three triangles in the diagram. All right, you are going to try to write yours here. If you need to redraw the picture again, awesome. If you can kind of start to see some of those relationships without drawing it, that's awesome as well. So the video is going to stop here and give you a chance to try this one. All right, here you can kind of see my redrawing. I have my blue medium triangle here and here. I've got my small green triangle here and here, and all my corresponding parts are aligned between the three triangles. All right, one last little thing we're going to talk about, because it's going to build on this idea soon, is this idea of what's called a geometric mean. Okay, so geometric mean. So Sometimes in proportions you have means that are equal, and that occurs quite frequently for us in geometry. When that occurs, we say that the extremes are then the geometric means. So it's interesting because this is kind of what it looks like. You can see that these means are both x, and if I want to solve for that x, I start to multiply my cross products. So I go a times b, and you probably want to write this part down, equals x times x. Well, what is x times x? That's x squared, so that now equals a times b. Well, if I want to solve for x, I have to get rid of that square. So we think about what gets rid of a square? A square root. So I take the square root of x squared, and then if I do that, take the square root of the other side, and I get x equals the square root of a times b. So a geometric mean of a number is like when you have the proportion, but it's the square root of the geometric mean of two numbers is the square root of their product. And so this is going to come up. We're just going to practice finding our geometric mean, and then we're actually going to use it in application in our triangles. So here it says find the geometric mean for each pair of numbers. So that tells us we're going to set up a proportion. Our geometric our means are both going to be the same thing, and then 6 and 15 are going to be our extremes. And now we cross multiply. We go 6 times 15 equals x times x, which is really x squared. Then we figure out that 6 times 15 is going to be 90. 90 now equals x squared. Now I have to finish solving for x by taking the square root of both sides. And I get x equals the square root of 90. However, the square root of 90 is not simplified enough. So this is one of the things that we do is we simplify our answers. We don't write them in decimal form. We just simplify them. So I think about a perfect square that goes into 90. My typical ones I always check are 2 squared, which is 4, 3 squared, which is 9, 5 squared, which is 25, and 7 squared, which is 49. Those are kind of the first ones I check before I look for anything else. I actually realize that 9 goes into that, so I can split it now into the square root of 9 times 10, which equals x. That I can now split into the square root of 9 times the square root of 10, which equals x. And I know the square root of 9. It's 3, and it becomes 3 root 10 equals x. I double check what goes into 10. 2 times 5. That doesn't work. So my answer is 3 root 10 equals x. Let's try another one together. So once again, we set up our proportion. 10 and 12 are our extremes. X will be our means. So we cross multiply now. 10 times 12 is 120. X times x is x squared. However, now I have to simplify that, so I take the square root of x squared, which gets me an x, and I take the square root of 120. Now I start to think about what goes into 120. I know 10 times 12. I know 2 times 60. None of those are perfect squares. I realize, though, now that it's an even number, so if 2 goes into it, maybe 4 does. A quick check on my calculator. Oh, 4 does go into it 30 times, so I change it into 4 times 30. I now take the square root of both parts, square root of 4 times square root of 30. I know the square root of 4 is 2, so I get 2 root 30 equals x. Now I just pause to think about the factors of 30. I know it's 1 times 30, 2 times 15, 3 times 10, 5 times 6. None of those are perfect squares, so none of them go into 30. So my answer then is 2 root 30. All right, you've got 2 more. I'm actually going to pause the video and have you try these and then check your answers when you're done. And then that'll be the end of it. All right, you can check your work and answer to both of these. The first one, I got 4 root 5 for my answer. The second one, 64 actually was a perfect square, which was nice. Someone took the square root of that and I got 8, so x equaled 8. That's as far as we're going to go.